In one-dimensional array, the data elements are stored either in one row or in one column. All of you know that in computer memory, it is always stores the first data item or first address of data items are stored in computer memory. In one-dimensional array, we use only one subscript, but here we are using two subscripts, one for row and one for column. Dear students, welcome to CS classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the concept memory representation of two-dimensional array and row major order and column major order. Now let us see the definition of two-dimensional array. Students, in our previous sessions, we have discussed about the one-dimensional array. What is one-dimensional array? In one-dimensional array, the data elements are stored either in one row or in one column. And one more definition, we can say that here the data items are represented by using one subscript. Now let us see what is two-dimensional array. Here, two-dimensional array is nothing but the data items are arranged in more than one row and one column, and here we represent the particular data item with two subscripts. That is, look at the definition. The two-dimensional array is a collection of data elements, and each element is identified by a pair of indices called subscripts. In one-dimensional array, we use only one subscript, but here we are using two subscripts, one for row and one for column. And the elements are stored in continuous memory location. Same thing what you have seen in one-dimensional array. Array is a linear data structure. Here, all the elements are stored in continuous memory locations. And we logically represent the elements of two-dimensional array as rows and columns. This is how we represent logically. So that is why we say here in two-dimensional array, the data items are stored in more than one row and one column. And here we represent the data items with two subscripts, one for row and one for column. Now let us see the next slide. If a two-dimensional array has m rows and n columns, here m is number of rows and n is number of columns, because it is data items are stored in more than one row and one column. And then the number of elements, the elements are accessed using two indices I and j. Here I is one subscript, j is another subscript. Now, the number of rows and columns in a matrix is called as the order of the matrix and denoted as m into n. Here, m into n is nothing but order of the matrix. It is m stands for rows and n stands for column. For example, if I say A is name of an array with 5 and here 6. If you look at this example here, 5 is one subscript and 6 is another subscript. So this is the order 5 into 6. So here this is m rows and n columns. M rows and n columns. And here subscript, this is I and this is j. So here what is the order of the matrix in this example? Here that is m into n, that is 5 into 60, that is equals 30. So here the size of an array here, or we can say the order of the two-dimensional array in this example is m into n, that is 5 into 6, that is equals 30, or m into n. 5 into 6 is order of the matrix A. The number of elements can be obtained by multiplying number of rows and number of columns. Same thing here, number of rows, there are 5 rows and 6 columns. 5 into 6 equal to 30. So there it is possible to store 30 elements in a matrix of the order 5 into 6. So here always first one, the first index always stands for rows and second one always stands for column. That you have to keep in our mind. So this is the definition of two-dimensional array. Now look at this example. The total number of elements in the array would be rows into columns. 3 into 3, that is equal to 9. In this example, A is name of an array, and in this example, this is one row, second row, and this is row number 3. And number of columns, this is first column, second column, and third column. In this example, there are 3 rows and 3 columns, that is 3 into 3, that is equal to 9. So we can store 9 data elements in an array. This is two-dimensional array, more than one row and one column. And all of you know that in array, always the array subscripts start with 0. But in this example, there are 2 subscripts, that is I and J. So at the beginning, that is always A, name of an array, it is 0 and this is 0. This will be the first index of two-dimensional array. So here A is name of an array. I here in this example, first index is 0, second index 0. Here first index, for example, I, J, I stands for rows and J stands for column. So always array subscripts start with the index 0 in one-dimensional array and 0 and 0 in two-dimensional array. So accordingly, if you look at the memory address location, or if you look at the example, now how can we access the elements of an array, two-dimensional array? If you look into that, this is index 0, 1, 2, 0, 1, 2. The memory address location or address of this element 2 is 0, 0. That is A of 0, 0. A of 0, 0, it represents the element 2. Similarly, here if you talk about element minus 2, it is A of 0, this is 0, 1. So if write A of 0, this is for row and column is 1. Column is 1. So A of 0 and 1, it represents the data item, that is minus 2. So this is how we access the elements of two-dimensional array with the 2 subscripts I and J. One stands for row and column. Always first index stands for row, second index for column. Similarly, suppose if you want to access the data element 5, then the location address would be A of, this is row number is index is 2, A of 2, and here column index is 2, that is 2. So here A of 2 and 2 represent the data element 5. So this is how we logically represent two-dimensional array and number of rows and number of columns. And size of an array will be number of rows into number of columns. In this example, 3 into 3, 9. So size of an array is 9. So we can store 9 elements. Now let us see how we can represent in computer memory, or how the elements are arranged in computer memory for two-dimensional array. Now in this example, suppose A is an array of order m into n. To store m into n number of elements, we need m into n memory locations. The elements should be in the contiguous memory locations. And here, suppose you know how to find the size of an array. That is by multiplying number of rows into number of columns. So in this example, m into n, if you multiply this, these are the number of elements to be stored in an array. But at the same time, we need to have m into n memory locations to store m into n items or m into n data elements. So here there are 2 methods to store the values in computer memory. One is row major order, second one is column major order. Now let us see the definition of these two. First one is row major order. Look at the example. Here, consider an array of the order 3 into 3. 3 into 3, 3 rows and 3 columns. This is an example here. This is the index as we have seen in our previous slide. Index 0, 0, 0, 1 and 0, 2 and so on. In this example, there are 3 rows and 2 minus 2, 3 are the first row elements, 1, 0 minus 3 are second row elements, 2, 2, 5 are the third row element. In row major order, what normally we do is, here in computer memory, the first row elements are stored first, then second row elements are stored next, and finally the third row elements are stored in computer memory. Now look at the example here. Now consider this. In this one, for example, this is the memory address of the each data item. It is, for example, 2001, 2, 3, 4, 5, 6, 7, 8, 9 because there are 9 elements. So it should be 9 different memory address. So what is the location or what is the data item stored in the address 2001? So if you look at this example, here first row elements 2, minus 2, 3 are the first row elements, and 1, 0, minus 3 are the second row elements, 2, 2, 5 are the third row elements. Now just to observe this, in this example, first row 2, minus 2, 3. 2, minus 2, 3. So in this example, if you look at the index, 2 index is 0, 0. Index of 2 is 0, 0, 0, 1 and 0, 2. So look at the same example here, 0, 1, 0, 0, 0, 0, 1, 0, 2. These are the first row elements. So as per the definition, the first row elements are stored in the first memory address. Because your memory address is also in a continuous memory locations. So 2001 is the memory address of first element, second element and so on. So here first row elements are stored in the first computer memory address. Next, after that, second row elements, if you look at the example here, 1, 0, minus 3 are the second row elements. Index is 1, 0, 1, 1 and 1, 2 here. Now look at this example here, 1, 0, 1, 1, 1, 2. This is the index of second row element. These are the data items. These data items are stored in the memory address 2004, 5 and 6. Similarly, even for third row element. So this is how the data items are stored in row major order. Now let us see the definition. Let A be an array of the order m into n. In a row major order, all the first row elements are stored in sequential memory locations, and then all the second row elements are stored and so on. This is what you have seen in the example now. First row elements are stored in a memory location, next second row elements and third row elements. Now here is an example. Here is one formula here. So with the help of this formula, it is possible for us to find out the location or the memory address of a particular element. For example, look at this example here. So in this one, I would like to know the memory address of the data item 2 here in this. Now, if we know the index 2A of 2 and 1 is the index, not memory address. So if it is possible for us to find out the memory address of the any data item in two-dimensional array, it is possible by using the formula. This is the formula. Now in the formula is location of A of I comma j is base address A plus W n I minus LB plus j minus LB. In this example, A is the address of the first element of an array or two-dimensional array, and all of you know that in computer memory it is always stores the first data item or first address of data items are stored in computer memory. So accordingly, this A is the base address in the sense the address of the first data item of two-dimensional array, and the memory address of any element a of I comma j. Suppose I would like to know what is the memory address of the element a of I comma j, and it is obtained by the formula this. Here base a plus w n into I minus lb plus j minus lb. Now, where w is the number of words per memory location, it depends on the data type of an array. So this is the formula. Now let us move on to column measure order. But now look at what is column measure order. In column measure order, the first column elements are stored in the memory address first, next second column elements, and next one is third column elements. So this is how the elements are stored in column measure order. Now let us say an example. Consider the same example here. In this example, there are 3 rows and 3 columns. These are the indices. Now, if you want to store in column measure order, as per the definition, the column elements are stored first in the first memory address, next second column elements, and next third column elements. These are stored in order. Now, consider the example now. In this example, as we have seen in the previous slide, this is the memory address of different data items, and the memory address are in continuous numbers, and these are the data elements, data items, and these are the locations. Now, if you look at this example here, now here 0, 0 is 2, 0, 1 is minus 2, 0, 2 is 3, and the first column element 2, 1, 2. Here if you look at the index of this, a of 0, 0 is first element, a of 1, 0, and a of 2, 0. These are the first column elements. Now, how we can store this in computer memory? Look at this example, look at the table here. So these are the values. First column element 2, 1, 2, and second column elements are minus 2, 0, 2, and next column element is elements are 3, minus 3, and 5, and these are the index of of each data item. And if you observe this, these are the first column element, these 3 are second column element, and these 3 are third column element. Now, as per the definition, this address remains same 2001 to up to 2009 because 9 elements. So there are 9 different memory address. So here 212 is the first column elements are stored from the first memory address. Next address 456 is for second column element, and memory address 200789 for third column elements. So this is how the values or data items are stored in computer memory in column measure order. Now let us see an example. This is the formula here. So with the help of this formula, it is possible for us to find the memory address of any data item in 2-dimensional array. Now look at the example here of the formula. Same thing here, location of a of I comma j. This is we would like to know what is the address of a, name of an array, I, j, or the index. Formula base a plus w I minus lb plus m j minus lb, close the bracket. And here w is stand for number of words. As I told you, it depends on the data type of an array. Now consider one simple example here. Consider an array of a of order 25 into 4 with base value 2000 and 1 word per memory location. Find the address of a of 12, 12 and 3 in a row measure order and column measure order. Please note down there is a difference in the formula for row measure order as well as column measure order. Now consider this is for row measure order. Formula is location a of ij equals b base address. See, this is the formula given. Now these are the values. First substitute the values for all the variables given here. See here, base, this is base a, this is a base address is 2000. It will be given, though 2000 will be the memory address of first data item in two-dimensional array. Next, m into n. This is the order of m into n, that is 25 into 4. 25 rows, and this is 4 columns, m into n, rows and columns. And here LB stands for lower bound, it is always 0, and W is 1 as per the definition. W is 1 and I is 12, J is 3. What is I? This is I is 12, J is 3. This is, we would like to know, we would like to find out the memory address of A of 12 and 3. As now in row measure order, this is the formula. Now, so we have to substitute these values into in the formula. Location of A of 12, 3. See, this the base address is 2000, and as per the formula, W is 1, he given here, and this is 4. Here, what is 4 here? Column. N equal to 4 into, as per the formula, L, this is, sorry, I minus LB, lower bound is 0. I is I comma J, this I 12, and plus J is 3 here, minus lower bound is 0. So when you simplify this, we will get the answer as 2051. So 2051 is the memory address of the data item of the index A of 12, 3. So with the help of this formula, it is possible to find out the memory address of any data item in two-dimensional array stored in row measure order. Similarly, now let us find out the address of column measure order. So here, this is base address A, everything same data. Now only have to look at the formula. There is a difference in the formula for row measure order as well as column measure order. Now substitute all the values here. Here location 2000 plus 1, 12 minus 0 plus 25, 3 minus 0. Accordingly, we will get 2000 plus 21, that is 2087. So this is the memory address of the data item of the index A of 12, 3 stored stored as column measure order. So this is another example to find out the memory address of a data item in two-dimensional array. Now let us move on to next slide. Now let us see what are the different applications of arrays. Arrays are used to implement the data structures such as heaps, hash tables, queues and stack, strings, etc. See, these are the data structures. For stacks and queue, we are going to learn in our further sessions. Now, arrays are used to implement mathematical vectors and matrices. It is, we are using this in mathematics as a matrices to store the values. Now, many databases include one-dimensional array whose elements are records, and these are used in database to store different records. Another applications, it is used to represent multiple data items of same type by using only one single name. So this is the definition of an array. So here, you know what is an array. Normally, if you say, if array, for example, A is name of an array with example 5. The meaning is, here it is size is 5. We can store 5 different values under one name. That is the meaning of this statement here. So number of values can be stored under one name. That is the advantage of an array. Now, it can be used to implement other data structure like linked list, stack, queues, trace and graph. These are you are going to learn in our next sessions. And two-dimensional array are used to represent matrices. This is in mathematics. We are using this to store values in the form of matrices. These are the advantages of array. Now, what are the drawbacks or limitations of an array? Disadvantages of arrays. We must know in advance that how many elements are to be stored in the array, or nothing but we should be knowing the size of an array. That is very important before we work with an array. Here, that is the meaning of we should know the size in advance. Before we start working with arrays, we should know the number of elements are stored or size of an array in advance. Array is a static data structure, and it means that array is of fixed size. Memory which is allocated to array cannot be increased or reduced. So array is a static structure. You know the meaning of what static means? It cannot be changed, it is fixed. So the meaning is, once the array size is declared in a program, those size or array, the size of an array cannot be increased or even cannot be reduced or even cannot be decreased. So that is the drawback of an array. Next, the elements of an array are stored in consecutive memory locations, and so insertion and deletions are very difficult and time consuming. And all of you know that array is an example of a linear data structure where all data items are stored in consecutive memory locations in definite order. So the operations what we have learned in our previous sessions, like insertion, deletion, and other operations, are complex in process and also time consuming. These are the drawbacks of arrays. We will continue our discussion in our next session. Thank you very much.